Good day, everyone. I am Sammy Militante from University of Antique, Sibbaluca, Philippines. Along with my co-authors are Nanette Dionisio and Brandon G. Sibbaluca. Today, we are going to present our research study entitled Pneumonia Detection Through Adaptive Deep Learning Models of Convolutional Neural Network. Pneumonia, it is an ailment that distracts the passage of air in the lungs, air sac of an infected person due to tissue inflammation that causes by the accumulation of fluids or pus. So pneumonia, it is usually triggered by bacterium, fungus, or virus that infects the alveoli of lungs that develops fluid discharges, especially to persons experiencing coldness, a rising body temperature, and breathing problems due to stuffy nose. So to find out if the patient has pneumonia, experts conduct physical exams and diagnose their patient through chest x-rays or ultrasound or biopsy of lungs. Misdiagnosis or inaccurate treatment, or if the disease is ignored, it may lead to the death of the patient. So our study employs flexible and efficient approaches of deep learning, applying 6 identified convolutional neural network in predicting and recognizing a patient unaffected or affected with the disease, employing chest x-ray images. So this includes the GoogleNet, the BGGNet 16 model, the AlexNet, the StrideNet, and the ResNet 50 models. So our objective is to determine the top model for the detection of pneumonia using CNN. Another is to evaluate each model in terms of accuracy, performance using hyperparameters, and optimization in pneumonia detection. So this is our proposed methodology. So convolutional neural network, so stimulated by the human brain, the convolutional neural network is a feed-forward neural network. So it is capable of extracting characterized features and classifies them, as you can see on the figure. So the standard convolutional neural layer acquires the image input that will create map features, through the kernels. So it works by taking each neuron from the preceding or succeeding layer. So it will increase the performance of the improved image because of the multiple neuron connections or network connections and overlapping with each other. So the sharing of weights, will reduce the number of parameters, and every connected convolutional layer, to the non-linear activation layer accelerates the CNN in more complex function that may lead to overfitting and pooling. So pooling is used to overcome the overfitting, and also it reduces the number of parameters, and the fully connected layers summarize the trained features in order to provide the classified result. So in this case, we have pneumonia, disease infected, and the normal. So the next is the pneumonia recognition framework. So we have first phase, the pneumonia infected and non-infected image collection. So the study employed the data set of the Radiological Society of the North America, or RSNA. It consists of a total of 28,000 chest x-ray images that are publicly available. So the images that we have collected are formatted in the JPEG format, and it is categorized into 2 classes. So the pneumonia, disease infected, and the normal or not infected with the pneumonia. So the next phase is the pneumonia image pre-processing. So all chest X-ray images acquired are independently cropped to generate a uniform measurement and to satisfy the requirement input for CNN architectures. All crop images are resized to 224 by 224 pixels, and the collected data were properly labeled by the experts, no, to precise labeling in classification, and they are divided into 80. So 80 is to 20 ratio, no? So 80% for training and 20% for testing. So the CNN parameters, the next phase is the CNN parameters setup. So we have batch size, learning rate, the number of epochs, and then the Adam optimizer. Next phase is the training, wherein we have the transfer learning, and then the fine tuning of our model, no? And then last phase we have the validation and testing. So result and analysis. So the tests were conducted using a laptop computer with a speed of up to 4.2 GHz, which contains 12 logical cores and a memory size of 16 GB and a video card with a size of 4 GB. So data augmentation methods is also adapted or integrated in the study. So it includes image rotation, image flipping, zoom, and shifting. So for the optimization of our model, we use the Adam and the categorical cross entropy. So for the batch size, we have used 32 and 64 batch size for 500 epochs, no, for all the models. So for the performance testing results, no, they are very acceptable since our 5 models attained a grade of 96% up to 98% accuracy rate during the training of their models, no? So the highest record we obtained is 98% by the GoogleNet and the Nanette model. 97%, no, was obtained by the BGGNet 16 model, while the StridedNet and the AlexNet model has both 96 mark using both, no, the batch size of 32 and 64. So we have the lowest recorded rate, no, which is attained by the ResNet 50 model, no, with a rate of 80%. So these are the result, no, of the during the testing. So in a Nanette model, we have the image, no, detected that it is infected with the pneumonia. 99% went 61, no, on the left. Another example, we have pneumonia is detected on the right image, you know, with a grade of 99.76%. So for the GoogleNet model, no, we have test it, no, we have 99.29%, no, it was detected that it is infected with the pneumonia on the left side of the image, and then on the right, it has detected a 99.47%. No? So for the BGG16 model, so this is an example output. So it has detected pneumonia based on the image input. So 99.53 and 98.43%. So using the AlexNet model, no, so it has detected that the image, no, is a normal, detected with a grade of 98.99%, and on the next side we have the pneumonia, it is infected with 99.83%. So for the StridedNet model, we have here the sample output during the testing. So pneumonia is detected with 97.43%, and then pneumonia is detected with 96.61%. And for the ResNet model, Pneumonia is detected 67.82% and 90.67%. So on the next slide, this is an example of an output, no, during the testing of all models, no. So with a normal detection, no. So these are the output for the Nanette model. So it has detected, no, that this image on the left side, it is a normal with 100% mark. Then on the right side, we have the normal 99.68%. So for the Google Net model, so it obtained, no, the grade of 92.21% and 99.78%, no, as an example. So these are the output of BGG16 model, the AlexNet model, the StridedNet model, and then the RestNet model, no. So it shows the predicted, no, examples of normal chest X-ray using the 6 different models or 6 CNN models. So these are the result, no, of that during the training performance, no. So all the CNN architectures with the size of 32, batch size of 32, and the epochs of 500. Next, we have an output or a figure for the training performance and result of 6 trained architectures with the batch size of 64 and an epochs of 500. So for the conclusions, all the 6 identified CNN models were evaluated substantially to collect for feature extraction and fine-tuning for its framework. So the researchers were able to categorize among the 6 model the best model to identify pneumonia disease. No? GoogleNet and Nanette, no, are the top model based on the performance accuracy with a grade of 98% during the training of the models. So while the BGG16, the AlexNet and StridedNet, no, achieve a very satisfactory performance with the mark or the grade of 96 to 97%. And we have lastly, we have the ResNet 50, no, which gained, no, the lowest mark, no, among the 6 models with the accuracy rate of 80%. So for the recommendation, the authors, no, recommend that an adaptation of other convolutional neural network architectures like Inception B3, ShuffleNet, and MobileNet architectures, no, may be integrated in the future, no, research. Optimization of hyperparameters should also be considered to improve the accuracy of the model. So that's all. Thank you.